We are back with this AutoML. In the last session, we had set the AutoML and we said that we'll come back and observe the outcome. So here you can see that this status has changed to model training. That means what this AutoML is doing is uh, uh, it has taken the data set and has started to train various kind of models that is there in its library. And if you go to the models and child jobs, you see that already so many different models have got trained. Okay, so it has started with this, and then it went to this one, then to this one, like that, and it is giving the AUC weighted. So while we are setting up the model, we have to also say that what is the parameter on which you are going to measure the accuracy of the model. And we have said AUC or area under the curve. So what it's trying to do, it is progressively trying to improve the area under the curve. So it is taking different models, it is fine-tuning the model, and it is finding out what is the area under the curve, and this area under the curve is going to give you the accuracy of the model. Okay, so this is how it is coming up. So we will it will take a little bit of time to get some of the models experimented and finally arrive at the most uh, accurate model. We'll wait for some time while it is experimenting different models, and we'll come back and we'll probably not wait for the final model because that might take a little bit of time. Normally it takes half an hour to 45 minutes for it to experiment all the models and then find out what is the most relevant model or the model that has the highest accuracy and suggest that model. But we'll probably not go up to that. It can kind of stop in between and we can stop the job and then take any of these models and deploy the model. Okay, so probably we'll do that. So, but we'll come back after it has done some more experiments. Okay, so we are back. As you can see that already it has tried with various models. And if you remember last time we saw this, we had this AUC of around 0.79 and now it has tried some other models and the AUC is 0.83. So it is still experimenting, it's still training with other models. And as I said, it will probably take half an hour, 45 minutes before it can uh, come to a model which is the best uh, based on whatever model libraries it has. So it will explore all the model libraries it has inside it repository and come out with the best model. We'll not wait for that long. We'll probably cancel this, and at any point of time, we can cancel this. And we can also cancel it if we are happy with this result that, okay, 0.83 0.83 AUC. If we're happy with this result, we can just cancel it and we can deploy that particular model. So probably we'll not wait for that. But before we do that, few other things that I wanted to show you. For example, if you go to the data guardrails, I was talking about that when you uploaded the data, it did not ask anything about pre-processing or seeing if the data set is imbalanced. If you see that it has already done all this validation, it has validated whether the data has been split for validation purpose. It has checked whether there is any class imbalance, whether it has checked whether there is a missing value, whether there is high cardinality features. All these things it has already checked. And if things were okay, that means these values are not significantly affecting the model performance, it will probably correct it itself. Otherwise, it may come back and tell you that, okay, you have to do some pre-processing on this if there's a huge class imbalance or if there's a huge set of missing values, etc., which is beyond something that can be done automatically. So those are the places where, again, a data scientist has to come, the manual intervention has to come in. But the major advantage here is that the hyperparameter tuning and the feature engineering, which is a very, very repetitive task that can be fully automated through this AutoML. So we'll go to this child job and the model and child job, and we'll also see that under these jobs there are you can even see the hyperparameters. What are the hyperparameters that it has taken? Okay, so it has use light GBM classifier. What are the hyperparameters it has done? You can even view the generated code. If you want, you can take this code. The Python code. So you can, if you want, you can take this code outside and do your own editing and then run your own code if you want to. So this is the code that is used. If you want to fine tune this particular code, you can do that as well. So it is very, very transparent. It is not that it is keeping the code to itself. It is giving the code back to you. And if you want to further fine tune it, you can do that. Okay. So a lot of facilities. So at this point of time, we are going to stop this, cancel this job. It's not going to search for further models. And it will take some time to get canceled. And once the job is canceled after some time, the out of the jobs that uh, it has already evaluated, out of the models that already evaluated, it will give an explanation for the model that it has found as the most accurate. Okay, so we'll come back to this after a few seconds and see what the explanation of the model looks like. So if this is the model that we plan to deploy, and you can see I can deploy this from right from here, the real-time deployment batch endpoint web service, something that we have done in the manual model. Okay. Uh, Now, one of the important things is the explanation of the model, because in an AutoML, it's true for normal ML also, especially for deep learning, but in AutoML more so because we don't know what are the parameters against which the model has predicted. And if somebody comes and asks the right to information that, okay, if my application has been rejected, what is the reason my application got rejected? Then we are liable to explain that why the application got rejected. So explainability of model is becoming more and more important in today's context. This is called explainable AI or XAI. Okay. So we can get an explanation of this model. So if we just go over here and say explain model, let's say this is the model that we want to deploy because this has the best result. Go to explain model, we can select the compute instance, create. Is going to create a explainability job. So what we'll do, we will complete this video here, and in the next video, we are going to come back and see how we can look at the model explanation for the model that we have selected.